I am M.W. Penn, and I have a great job. I teach math concepts to young children, and I have a lot of fun doing it. I think they have fun too, but don't tell them it's math. This is King Sidney the Silly, who only eats 6. When children read about King Sidney, they don't know that they're learning number comparison. What they're learning is a lot of poetry and reading a rollicking rhyme. King Sidney is silly, he only eats 6. 6 string beans, 6 peanuts, 6 peppermint sticks, 6 jelly sandwiches, 6 apple pies, 6 baked potatoes with sand in their eyes. Well, you get the idea of what Sidney eats. Once Sidney was eating a 6th tiny pie. He counted 6 cherries, then 7. Oh my, 7 sweet cherries. What would Sidney do? Well, Sidney hid one cherry under his shoe. He squished it and squashed it and made a big spot. Was King Sidney sorry? King Sidney was not. I won't eat that cherry. Don't try any tricks. I'm Sidney. I'm silly. I only eat 6. The chef from the palace, Brawley from Brix's, he's a wonderful chef, but he only makes 6s, which leads to a confrontation between Sidney and Brawley. It's a fun story, but children are comparing numbers all through it. And when they're very young, number comparison is something that they really have to learn. We do have a workbook that goes with Sidney, and what I found with using this workbook is that it involves a lot of people who live in the palace. Sidney's tutor is symmetric, perfectly symmetric on both sides. And the odd job man, Oscar, only likes odd numbers. So we teach a lot of math through stories and have a lot of fun doing it. How do you teach math in a story? Well, this is Square Bear. Square Bear happens to be a polygon. He lives in a beautiful polygon palace with the polygon princess, triangle prince, and rectangle horse. All 2-dimensional shapes that are polygons. But then the fierce disc dragon enters the scene. What's wrong with the disc dragon? Well, he's not a polygon. When he captures the beautiful, beautiful polygon princess, we must eliminate the disc dragon. Well, how does a 5-year-old eliminate a dragon? We just erase him from the page. By the end of the story, the children are having a lot of fun, and they can tell you what a polygon is. Then Square Bear meets Round Hound, another non-polygon. Well, do you think Square Bear likes Round Hound? Not really. He's quite afraid of her, because the only thing he's seen that is not a polygon is the disc dragon. This is a story about learning about people who are different than you, and it's also a story about shapes in a 1-dimensional or 2-dimensional space. So that's how we teach children mathematics. This is That's Not a Beagle. What can we teach with That's Not a Beagle? How about set theory? Sets, relations, functions, groups, rings, fields. Higher mathematics. But 3-year-olds, 4-year-olds, 5-year-olds can tell you that when the alien in the story brings a little boy what he thinks is a beagle, the little boy will say, wait, that's a train. That's not a beagle. A beagle doesn't run on tracks. Oh, okay, so the alien will then bring the little boy a car. Wait, that's not a beagle. A beagle doesn't have wheels. Oh, okay, a beagle might have legs. Well, how about a chair? A chair has legs. It's a story of attributes, categorization, and the way we categorize using Venn diagrams. We have a lot of games in the back of these books, which is another way to teach children about mathematics. In something like Round Hound, there are a series of concentric circles. Do you know what a concentric circle is? Concentric circles all have the same center, but they spread outward as they get larger. You might think of a dartboard. If you put a different geometric shape in each concentric circle and have a child drop a penny on the dartboard, they'll come up with a series of different geometric shapes. Have them make an alien or any sort of animal out of a fantastic animal out of these different shapes and write a story about it. Literature, mathematics, and a lot of fun. So that's what I do. I have fun with mathematics. This is Flibberty Digit and Flummery Daubs. It's a series of poems about mathematics. And one of the things in Flibberty Digits and Flummery Daubs are 9 monsters in a square. 9 monsters in a square. Tell me how they got in there. 9 monsters. Hear one say, "Come and help me get away." 9 monsters. Hear one shout, "Come on in and get me out." 9 monsters in a square. Come and help them if you dare. What's the unusual thing about 9 monsters in a square? Have children make a monster square. Just give them a square piece of paper and draw any sort of monster on it. Give them several. Have them do 2 monsters, 3 monsters, 4 monsters, 5 monsters. How many monsters can make a square? Well, 1 monster does. How about 2? Can you make a larger monster square out of 2 monsters? Well, they can't. How about 3? But 4 monsters can easily be fit into a square. So have them try 5 monsters, or 6, or 7. Very often, they'll try 8. They think that 8 is a very good number of monsters to put into a square, but it doesn't work. No, 9 monsters make a square. What's the next number of monster squares that will make a large square? Children often guess 12, and that's a very nice number, but it doesn't work. The next one is 16. Aha, they finally see the relationship between monster squares and square numbers. The only number of monsters that you can put into a square is a square number of monsters, and a relationship between geometry and number becomes apparent. So, yeah, I teach mathematics, and I love it, and children have a lot of fun when I'm in the classroom teaching them math. So try it. Thank you.